In this session, I'm going to attempt to explain the difference between the CG and the line of thrust on a bicopter. On all other types of copters, this is not an issue because normally the CG and the line of thrust matches. However, with a bicopter, we have a pivoting axis where the motor and prop pivot in order to create thrust vectoring. Now with Mini Moly 2, I have some baseline numbers here. This here is the pivoting point, or the point that connects to the frame, and this is the line of force that is applied when the props are spinning. When the prop motor rotates forward for forward flight a maximum of 15 degrees, we have an offset of Y here. So this is the downward thrust point, the thrust line. This is when it's hovering. So this difference here is what creates the pendulum, or the pendulum effect, and the reason why the copter rocks back and forward. Now there's two ways to address this issue that I have come up with at this stage. One is a static CG. That's where that we tune the copter for forward flight by offsetting the CG to balance forward. And this is calculated by, okay, I used a maximum of 15 degrees forward tilt, which this distance, the motor distance from the point of rotation to the base of the prop, is 1.75 inches. So that means that at a maximum of 15 degrees, the line of thrust will be offset by 0.453, almost a half inch. So if we place our battery somewhere in between this point here, it will level out during forward flight before it reaches the maximum of 15 degrees rotation. That's static. And this is on an FAAT copter. Now, I have come up with a new method of dynamically changing the CG, and I call it the weight shifting technology. And what this does is that the CG follows the line of thrust. As the props rotate forward, the CG also moves forward to stay in line with the line of thrust. This causes the copter to fly at a level state instead of tilting forward as your traditional quadcopter and tricopters do. So this copter will remain level at any stage or speed variance in forward flight, which is the desired result.